Today we are going to discuss about the further topics with respect to downsampling and upsampling, and mainly our focuses will be on how are we going to convert the sampling rate by a rational factor of I by d. And we know upsampling and we know downsampling, and we know how to upsample a particular signal by a rate of I, and we also know how are we going to downsample the signal by a rate of d. But if the ratio of I by d is there, in what way the given input signal can be converted at what particular rate, and what is that particular rate, and all this analysis we are going to discuss in this particular topic. So it is mainly a factor can be achieved first by performing the interpolation by a factor I, and then we'll try to perform the factor of decimation. We have a subsequent diagram which will also shows you how are we going to cascading, that is connecting it together, then interpolation followed by a decimation. We know that whenever there are two filters will be used in two different analysis of a decimation interpolation: anti-aliasing filters with respect to our decimation, and anti-imaging filters with respect to our interpolation. So they must be operated at a sampling rate, and hence we are going to replace a simple low pass filter with a transfer function. So when there is a multiple filters or exist, we will be used some kind of a low pass filter where the cutoff frequency will be equal to minimum value of pi by I comma pi by d, and this is the condition where we are going to define, or we are going to be check for rational factor of I by d. So as I clearly mentioned that the cascading features will going to lead us to perform both upsampling as well as a downsampling. So it is very clearly written here. So if we see the first block for the first section, it is purely an interpolator, and we see the second block, it is purely a decimator, right? And here what are we going to use is nothing but the combination of the interpolation and the depolation. So upsampler should be there, there must be downsampler should be there, and in between we do have two filters, and these two filters will be combined together and made it as a single analysis, single filter, and then the diagram B represents the corrective cascade process of the decimation and the interpolation. Now, as we learned the theory how the sampling rate conversion is going to be performed with respect to the cascading principle of first performing the interpolation and then followed by performing the decimation. Let me give an example for it which will suppose and we will further understand the concept of the rational factor by a factor of I by d. The given sequence x of n is given as 1, 3, 2, 5, 4, minus 1, minus 2, 6, minus 3, 7, 8 and 9. And they have asked us to demonstrate, show the effect of cascading downsampler and an upsampler, and if it is interchangeable. What do you mean by interchangeable? First decimation was kept and then followed by the interpolation, or if you want to perform the interpolation first followed by a decimation, that is what going to be performed. So what they are going to do is nothing but given signal x of n, they are made. Let d is equal to 2 and I is equal to 3. It's a factor which we have considered for our example. So decimated by a factor 2 and interpolation by a factor 3. So d and I are the co-prime numbers. So the given signal xt of n will be taken. What is xt? The given input signal which are to be sampled at a which interval it has to be sampled at a sample of 2. Only those samples will be picked up from the given x of n, whereas all the other samples will be removed. So we know the concept of downsampling, Downsample means downsample by a factor of d means at a regular intervals of d value the signal will be picked up and all other samples will be removed. So here the 0th sample is 1, the second sample is 2, the fourth sample is 4, and the sixth sample is minus 2, and 8th sample is minus 3, and 10th sample is 10, 8. Y1 of n, if you consider that by an interpolation factor, we will be performing this decimation followed by an interpolation. What do you mean by interpolation? Interpolation by a factor of what they have given, 3. So 3 in the sense what? Between the input signal and the third sample, the intermediate value 1 as well as 2 samples will be made as 0. That's what. So between this first sample and the second sample, how many zeros I need to put? 2 zeros. And that is what we have expanded, and we got the signal y1 of n is equal to this length sequence. Are we it's able to cleared? Yes. Now we will consider the further with respect to a diagrammatical view by doing the reverse as well as the first order itself. Right? So as I have taken an example, y1 of n is this. Here the decimation factor by a 2, and then we'll go for an interpolation factor. If we interchange that, what do you mean by interchanging? So interchanging is nothing but we will take this y1 of n as an input by a factor, and y2 of n is nothing but we need to calculate downsampled by a factor of how many samples? 2. Okay, wow. So we have to upsample by a rate of 3, and then we have to downsample. So upsample we already done it for the given input signal, so take that, and then we need to perform downsampling. Downsample for the given input signal x, this one. So which is nothing but what? Every second sample will be considered. The remaining all the signals will be totally removed from the analysis. Clear? Okay. So cascading of 1 equal to I equal to 3 and D is equal to 2, and this is what we are going to consider in the formation form. So now we could see that the cascading of I integrate of an upsampler and downsamplers are interchangeable, where I and D are co-prime. Now let me consider when they are not a co-prime. So for cascading diagram in the figure shown below, you can able to see that. So the given signal is this one, and the obtained interpolation factor by a factor of 4. So there will be 3 zeros will be there in between. Subsequent numbers, when they are not co-prime, we can infer that when they are not co-prime. So when it is not interchangeable. It's not interchangeable in the sense you cannot able to find any similar analysis take place between when we try to do that. So when we do this as well as this, we could not find any difference. We could able to maintain the same thing as the output here when we interchange. But when we try to reverse the concept also, when they are co-prime, when they are not co-prime, or we are not getting the same thing. So this indicates that when they are not a co-prime, the conclusion is it is interchangeable, is not valid. Thank you.